Okay, so today we're going to be talking about combining like terms and distributive property. Okay, so the couple of terms that we're going to be talking about, first of all, is an expression. Okay, so an expression is a math sentence that does not have an equal sign. We will be talking in the future about with an equal sign, which just means it's going to be called an equation. Our next term, is term. A single number, variable, or number and variable multiplied together. So an example of this could be 1 or x squared, or maybe 2x, okay? Next is a constant. A constant is just any number. Could be 0, 1, 2, etc. And then finally, we're going to be talking about the distributive property, which is a property that enables you to multiply a sum by multiplying each addend separately. So we'll be looking at problems where there is a number sitting in front of possibly two terms that we're going to have to multiply to both. Okay, so let's go ahead and look at how we're going to be referring to these terms. Today I'm going to be using algebra tiles. Here, this is going to be our x squared. The rectangle here, that's going to represent our x. And then this last little square is going to represent our numbers or constants. Okay, so the first problem that I want to try to model is x plus 1. So if you remember, here's my x term, and here is my constant term. So x plus 1 would look just like this. This is already simplified because there is no other term that I can combine with this x or with this constant to simplify this anymore. So this would be considered a simplified expression. Okay, the next expression that I want to try to model is 2x minus 3. So I will use the x tiles and I will have 3 constants. Now we just need to make sure they're flipped on the right side. So these are 2 positive x's and 3 negative constants. So again, this is already simplified as much as it can go. Okay, so here is the next problem. 3x plus 4 plus 2x minus 1. And as you can tell, this is not simplified yet. So what we're going to have to do is simplify this expression. It's easy to visualize with the algebra tiles that these x terms all go together and that I can pair up a negative and positive pair, and those will cancel out and become 0, and this is what I would be left with. Now, algebraically, what I like to do sometimes is to make this a little bit more visual while I'm working it algebraically. So, what I'm going to do is I'm going to designate a certain shape for the x's. So I'm going to use squares, and then I'm going to use circles for my constants. So if I combine these terms, I end up with 5x here, because I have 3x plus 2x. And when I combine my constants, I end up with positive 3, because 4 minus 1 is 3. So if you notice, what I had simplified here was equivalent to what I have here. Okay, here's another problem. I'm looking at 3x plus 4 plus 2 times x minus 1. So here I have set up the 3x plus 4, and what I'm going to try to do is model the 2x minus 1. So you can think about this a couple of different ways. Remember, distributive property is going to multiply that 2 into both of those terms. So I can think about just doing that. 2 times x is going to give me 2x, and then 2 times negative 1 is going to give me negative 1. Or I can think about there being 2 sets of that x minus 1. So it's like I have x minus 1 and x minus 1. Okay, so algebraically, I'm going to end up having on my next step, 3x plus 4 plus 2x minus 2. So once I'm to this step, now I can start combining my like terms. So here it's easy to see these will combine. My 0 pairs will cancel out, and I'm going to be left with 5x plus 2. So now let's go ahead and work that out algebraically. So again, I'm going to use a shape here to designate my different terms. So I'm going to have 5x, and then here and here. Combine my constants, I end up with 4 minus 2, which is negative 2. Okay, here's one that you might want to try on your own. If you want to go ahead and do that, you can pause the video and then catch up with us when you're done. Okay, so I'm going to go ahead and work this out algebraically, and we'll also talk about the visuals along the way. So I'm going to go ahead and draw this. This would be the big x squared tile. This would be one of our small rectangles, but negative. This would be 2 negative 2's. And then over here, this is where I've got to use my distributive property. So what's important to keep in mind here is that in front of this set of parentheses, there's actually an invisible 1. So when I multiply that, this is actually going to become negative x squared, so that's going to be one of the larger squares, but negative. And then negative 1 times negative 3 is going to be positive 3. Okay, so again, if I'm writing this all out, I'm just going to bring down these terms, and here is where my change happens. Okay, so if you're wondering what happened to the parentheses here, what's sitting in front of those set is just a regular 1. So anything times 1 is just itself, so nothing changed there. So now I got down to the step where I can combine my like terms. So this time I'll be using squares for my x squared. I'm going to use a triangle for my x terms, and I only have one. And then I'll use a circle for my constants. So now I'm going to continue to combine my like terms. So x squared minus x squared, those actually cancel out. I end up with a 0. I can bring down my negative x, and then I'm left with positive 3 and negative 2. Almost forgot that. Okay, so negative 2 plus 3 is going to leave me with a positive 1. So this is my simplified expression. Okay, I hope that this video will help you, and I will see you next time.